Okay, Transmath 2 class, we are going to look at the notes for 2.7, and we're going to start looking at equivalent fractions. But before then, we're going to review where we were comparing fractions. So if you notice here, each one of these symbols is a less than symbol. Remember, less than symbols always point left, okay? So let's put these in the right order. We know that 2/3 is less than 4/3. We know that 1/4 is less than 2/4. We know that 8/8, even though these are both improper fractions, 8/8 is equal to 1. 15/10, the top is bigger than the bottom, so that's bigger than 1. So 8/8 is less than 15/10. Let's see, now 1/6. 1/6 is going to be less than 1/4. Now, remember, if you have ones in the denominator, the bottom number, if you split something up into 6 pieces, rather than, let's say if I have a Snickers bar, candy bar, and I cut it into 6 equal pieces, and then I share with 6 friends, compared to if I had cut it into 4 equal pieces, I'd be getting smaller pieces if I cut it into 6ths. Okay, 7/3 versus 7/2. Again, if the tops are the same, the one with the larger denominator is going to be smaller, because that means you're dividing it into more pieces. So 7/3 compared to 7/2. 7/3 would be less than 7/2. Okay, here are just some multiplication facts, so we have to kind of remember. 3 times what equals 9? So hopefully you remember that that would be 3 times 3. What number times 2 is 8? That would be 4. 4 times 3 is 12. 5 times 3 is 15. 3 times 6 is 18. 2 times 5 is 10. 4 times 5 is 20. 7 times 3 is 21. 6 times 3 is 18. And 4 times 4 is 16. So just some multiplication facts, and that's going to help us as we start making some equivalent fractions here. So one of the main points they want to bring up right away is that we can have different looking fractions that are all equivalent to the same amount. Because like if this was the whole, right, if I cut it in half, 1/2 would be this purple length. But if I cut it into fourths and took 2 of those fourths, 2/4 is exactly the same length as 1/2. And if I'd cut it into 8 equal pieces and took 4 of those 8 equal pieces, those would also be the same. That would be the same length as 1/2 or 2/4. So those are an example of equivalent fractions. Okay, so 1/2 equals 2/4. 1/2 also equals 4/8. They're all the same. Which means, like on a number line, they would basically occupy the exact same position. So 1/2 would be right there. 2/4, if we cut it into fourths, also right there. 4/8, same exact position. So equivalent fractions occupy the same location on a number line. All right. Let's skip past that. All right. So to create equivalent fractions, what you're going to do is multiply the numerator and the denominator by the same number. Now, what number do we multiply by? It just depends on what they're asking us to do, or what we would need for a common denominator. But the idea is, if we multiply the same number on the top and bottom, we're going to create what's called an equivalent fraction. So in this one, 3 times 5 on top would give me 15, and 8 times 5 on the bottom would be 40. So what we're saying then is that 3/8 and 15/40 are, we use the word equivalent. That means equal, but they look different. So if they look different, but they're equal, we use the word equivalent. Okay, so we're going to create some equivalent fractions here. They're just kind of doing the graphic. So we're taking the 3, which is the numerator, times something to equal 6. We're taking the denominator times something to equal 12. And so hopefully, so it's going to be the same thing. So hopefully you know that 3 times 2 is 6, 6 times 2 is 12. That's how we make them equivalent, okay? In part B, so we're saying, well, 1 times what number is 4? Obviously that's 4. And then 3 times what number is 12? Well, that's 4 as well. They should both be the same because we're making equivalent fractions. Okay, so 8/4. So here we just want to make some equivalent fractions. So really we can choose anything we want here. Let's just say we multiply by 2 on the top and on the bottom. So then we'll have 16/8. That's equivalent to 8/4. Let's say we multiply by 3. So we'd have 3 times 1 is 3, 6 times 3 is 18. So what we're saying then equivalent fractions here. These are also equivalent fractions. Okay, they look different, but they're the same value. All right, so some more practice. This is kind of what we were just doing. So 4 times what is 16? That would be 4 times 4. 5 times what is 20? That has to be 4. All right, on number 2, 3 times what is 6? That would be 3 times 2. 6 times what is 12? 6 times 2. So again, equivalent fractions there. 3/6 and 6/12 are equivalent. 7 times what is 35? That would be 7 times 5. 6 times what is 30? That would be 5. So now we know that 7/6 is equivalent to 35 over 30. Next one, 1 times 4 would be 4. 3 times 4 would be 12. So equivalent fractions, 1/3, 4/12. Number 5, 6 times what is 18? That would be 6 times 3. And then, well, 6 times 3 again to get 18. 6 over 6, same as 18 over 18. They have the same top and bottom number, both equal to 1. Okay, make equivalent fractions, fill in all the boxes. So here we can just choose whatever we want. And I wouldn't choose real big numbers, but let's just do, okay, let's do 2's here. Let's do, so that's 2 times 2 is 4. 3 times 2 is 6. I'll just keep going up by 1. We'll do 3's here, 3 and 3. 1 times 3 is 3. 6 times 3 is 18. We'll do 4 and 4 here. So we'll go 20 over 20. And I'm going to keep going a little bigger here. Practice our multiplying. 5 and 5 here. As long as they're the same top and bottom, we're making equivalent fractions. So that would be 40 over 20, equivalent to 8/4. And I'll go 6 and 6 here. 6 times 6, 36. 7 times 6, 42. So 7/6 is equivalent to 36 over 42. Okay, are the fractions equivalent? So that's what we want to ask ourselves. So 3/4. So did I multiply, and I'm wondering, if I got 5/8, so it looks like I multiplied by 2 there. If I multiply by 2 on top, do I get 5/8? Doesn't look like it. I think I'm going to get 6/8, which means these are not equal. They're not equivalent. Okay, so the way I did that was I looked and I said, well, to get from 4 to 8, they had to multiply by 2. But if you multiply by 2 on the top, you get 6. You don't get 5. So not equivalent there. Okay, so 1/2. And we want to know, is that equivalent to 5/10? So I had to multiply by 5, it looks like, to get a 10. And if I multiply 5 there, I get 5 over 10. Yes, that's right. That's equal. Okay. 4/6 and 2/3. Is 4/6 equal to 2/3? Well, let's start with the smaller one, okay? Let's go 2/3. And what do I multiply the 3 times to make 6? I'd have to go times 2, which means I have to multiply by 2 on the top, and I do get 4/6. So 4/6 and 2/3, those are equivalent. Okay? And that is everything. That's all of our equivalence relations in there in section 2.7. So you can do the worksheet for that section.